Hello. There are several applications of artificial intelligence, and the application which we consider in this video is knowledge mining. So, discovering knowledge inside the information, finding hidden patterns. So, let me clarify what the challenge here is that anybody can, not anybody, but talent can hit a target, but it's kind of difficult to hitting target when it's not visible. So, we are going to get to that target. So this is the sequence of this video. So what is bi-clustering? I'll briefly describe, give examples. This video is more of visual nature. So what is the complexity of bi-clustering in terms of the teraflops required and some of the applications of bi-clustering and how we can use simulated data because then it gives a lot of control to perform bi-clustering and to quantify the results visually also. And then of course working with real data also. And then the final epilogue. So what is bi-clustering? So if you look at this table here at your left side of the screen, so this is sales and the items and transactions. So that's raw input. Now, if I make a correlation matrix, so basically I'm making pairwise row by row. So this is going to be a square matrix and symmetric matrix and correlations between +1 and -1 with red shades and +1 and green shades. So this is what we have. So from here we come to here. Now, if we perform clustering of this simulated matrix, this is what we get. And you can see very nice clusters here. And what is visible here is a global picture because we can see three clusters here, and we can also see the correlation between this cluster and these two clusters by these red regions. And these two clusters, they are not negative. They have certain negative correlation, but that is not very significant and so on. So but you can do a lot of analysis here. So this is what is a one-way clustering, or it gives the global view. Now, if we again work with the same matrix, sales matrix and the items matrix, and we rearrange, permute the rows and columns, okay, how we do that, that is a big question. And then these bi clusters are discovered. Bi means we have a subgroup of subset of rows and subset of columns. This is not market basket analysis. And then, of course, we can find that golden or valuable information. What is that information? Is the joint sales with respect to time of different products which don't have apparently any relationship between them. So what we have, this is the input, this is the output, and we have a two-way or bi-clustering. So the objective of this video is bi-clustering. And now this may seem nonsense, that makes some sense. And of course, that makes a lot of sense. So what is the complexity of bi-clustering? So if you look at this steak here, and we convert that steak into minced meat, that is fairly trivial. But what is not trivial is converting the minced meat back to steak is very difficult. And this is this is the complexity of the problem we are tackling. So this is the input, again the same input here, and this is the output which we want to achieve by permuting the rows and columns. So if you look at a very small problem here with the number of transactions being 100 and the number of items being 10, so that's quite a large number on a teraflop machine that takes about more than 100 million years. So what we are looking at is a reverse meat grinder, that is we are converting the steak back into from where it came from, okay, back to where it came from. So this is the input here, and I've color coded the by clusters, added noise shown by black dots, removed some data shown by white dots, and randomized it. And if we try to find the pattern here using the traditional DB scan approach, we can see that without rearranging rows and columns, this basically becomes part of this also, which is wrong. And there are other approaches by permuting the rows and columns, as in Chang and Church approach, at your extreme right, which of course is better than the middle one. So let's move on if we can do better. So applications of bi-clustering, there are many applications of bi-clustering. Applications in business and marketing, applications in finance. The further details are listed. Applications in healthcare, which is a traditional domain of bi-clustering. Applications in security, applications in education, and the list goes on. So let's start with the simulated data. So what we do is we create the simulated data. So using any painting tool, you can create any number of bi-clusters of any shapes, any color, any form, any order, any arrangement. Here is simplified version. So I have this image. So what I do is that then I load that image and convert that image into numbers because all the working takes place with numbers. And then I can add noise also, and I can permute it to my heart's content. So I did some noise, I permuted it, and then I store it also. And of course, I have created junk. So this is the clean text file corresponding to the image which we loaded, which we generated. So this is a perfect conversion. And from image to numbers to image. And this is the junk which I refer to. So you can see it really looks like junk. Now we will try to get back to from where we started. So this is that simulated data set permuted. This is the discrete version binary values. And these are the bi-clustering results, almost perfect. So that now we need to extract those bi-clusters. extracting the bioclusters, this will become very clear to you very shortly. So these are certain parameters, these are certain extraction techniques, and we perform the bioclustering. The bioclusters are extracted and they are written to an Excel file. So we open that Excel file. So this is the size of the data matrix or the small database, and these are the parameters. These are the number of clusters, and this is the details of cluster number one. The top of cluster number one, we can see that the order of columns have changed and the order of rows have changed. Why? Because it's a bicluster. And this is the bottom of that first bicluster, and these are the descriptive statistics. And this is, and then the second bicluster starts. So finally, what we had, we started from a clean approach. We added salt and pepper noise, and then I permuted it a number of times. And this is the junk which I was calling, and then we get back the results. Of course, we can perform cluster extraction also, and this took less than a second. Now we start. I'll show you working with real data. So this real data is about the questions and exams of students. And here's the reference here: computer-based complex problem solving, and we have the city subway concession and individual trip for and so on. So this is a large data set, and what I did was that instead of processing all the numbers, so I saved that data set as an image and then loaded that image, converted into numbers, and worked on it. So this is the same data set, and the clusters have bicluster has been identified for the input. So this is without biclustering. So on their default value, biclusters were restricted 488 biclusters, and it doesn't make a lot of sense. So then the biclustering takes place, and we can see the grouping and biclusters have appeared. Now that will be very useful if we can actually work on them. So this is an analogy of the meat analogy again. So we have more fat in this meat, in this ground beef, ground meat sample, and here we have low fat. So this is basically the percentage I am corresponding to the density of this matrix. But the density is 11%, which is the default value. So we have 220 biclusters, and you can see here, and these biclusters are numbered also, and these numbers match with the number in the Excel file. So analysis is very straightforward. And then we have changed the density to 60%, and we have 164 biclusters. As you can see, on this region there were multiple biclusters when the density was less, but when the density is high, then we have probably one or two biclusters in that particular region. So that's, and then of course is the Excel file, and we have the details here. And for the again, the order of rows and columns have changed. These are the descriptive statistics, and this Excel file can be integrated in any tool for further analysis. So where to go from here? So here are a number of directions to move, and thank you for your time and patience.